Hey everyone, we're going to take a look at exercise 42, which is all about proving theorems. And I want to make it clear to you that you almost always have to use those two facts. Every even number can be written as 2n, and every odd number can be written as 2n plus 1. Because you have to rewrite that what you're going to do in those proofs to something of those forms most of the times. What do I mean with that? Let's take a look. The sum of two even numbers is even. Try this. 2 plus 4 is 6. That's okay. 8 plus 4 is 12. 20 plus 12 is 32. It's always going to be even. But we can prove that it's always even. In this case, I have to first write down my first number and describe it as an even number. So let's call my first number, for example, 2n. That's my first even number. It's of this form, right? 2n. You could also say, the book sometimes do this, they say, we call a this. A is 2n. So a is my first even number. Well, how can I call my second even number, b? Well, not 2n again. Why not? Well, let's say I say it's also 2n. Then that means a and b must be the same number. And that doesn't have to be true, right? B can be a different even number. For example, a can be 2 and b can be 4. Or a can be 8 and b can be 10. So I cannot use the same number n, but I can use any other number. For example, k. So that my first even number is described as 2n, my second even number is described as 2k. The sum means in this case a plus b. Or you could say 2n plus 2k. Okay? Now we have to rewrite this to this form, something 2 times a letter, because that's the form for an even number, and I want to prove that it's always an even number. The most common way that you're going to do now is you're going to bring a common factor outside of my brackets. What's the common factor between 2n and 2k? Well, that's going to be the number 2, right? So I find 2n plus. Okay. And now you think, well, why have I done this? Well, because I can now rename n plus k to a natural number. This will be a natural number. This will be, if n and k were natural numbers, this will be a natural number again. So I can call this, for example, the natural number p. Or using any others. I often use p or I use l. Just another natural number. So n plus k is going to give you p. What p is, I don't care, but I can now substitute p into this part and say, well, so to be more exact, I can also say that a plus b is equal to 2p. And that is of the form like this. So a plus b is an even number because I can write it as 2 times a letter. So that means that in this case I am already done. The sum of a plus b, 2 even numbers, again gives me an even number. So I am done. How should I say? You could say thus a plus b is even. Sometimes mathematicians use this abbreviation, QED, which is a Latin abbreviation for I have proven that which has to be proven, or something like that, right? At least finish it with something that you say, I am done. Thus, this is true, or QED, etc. Let's try another one. Let's try B. Now I'm going to prove that 2 consecutive natural numbers are always odd. What is consecutive again? Opeenvolgend. Dus de som van 2 opeenvolgende natuurlijke getallen is oneven. That's always going to be true, right? 2 plus the next number 3 is 5. 6 plus 7 is 13. 9 plus 10 is 19. But prove why this is true. Let's take any natural number to start with. So my first number A is going to be, for example, K. Then my next number, B, is going to be a consecutive number. So the next number. How do I get from K to the next number? Yeah, I have to do K plus 1. The sum of those, so A plus B, is the same as saying K plus K plus 1. Or 2K plus 1 are like terms. And now I'm done already, because this is the form of an odd number. So here you can already say QED, or thus this is true, or etc. This is of the form 2K plus 1. So those two numbers added are always giving me an odd number again, because that's of the form 2n plus 1. Remember, which letter you have doesn't matter. Okay? I'm going to show you C as well, and I think after I've shown C, D is the same kind of exercise. The product of two even numbers is divisible by 4. Again, describe your first number. It's an even number, so I say 2K for example. Then the other number is also an even number, but it doesn't have to be the same one. So 2n for example. But now they say the product, so they say this number times that number. 2K times this number, which gives me 4KN. And now I'm not looking for an odd or an even number. No, I'm searching for a number that's always divisible by 4. And a number that's always divisible by 4 can be written like this, 4a, right? Or any other number, 4b, 4c. Because if a number is multiplied by 4, I can also always divide it by 4 again. So every multiple of 4 can be written as 4a. For example, 4, 8, 12, 16. So I want to rewrite this to this form. Yeah, I think the only thing that you have to do now is say, well, k times n is always going to be a natural number. I don't know which number, but it's going to be a natural number. Could be 10, could be 12, could be anything really. But if I'm now going to rewrite it, that means I can write it as 4 times p, 4 times any number, which means this is always going to be a multiple of 4 and always is going to be divisible by 4. Right, so here I'm already done. Every number that's done times 4 can also be divided by 4. Right? Shall I do D as well? Let's do D as well. I'm on a roll today. Doing quite some videos. The sum of two multiples of 5. A multiple of 5. So this time I start with a multiple of 5. Let's call it 5k. That's always going to be a multiple of 5. Then the other one is also a multiple of 5, but it doesn't have to be the same one. So I use a different letter. The sum of those, A plus B, is going to be 5k plus 5n. I want to show you that this is always a multiple of 5, which means I can rewrite it to this form again. 5a, 5c, etc. Can I do that? Yeah, use that trick again. Which trick? Bring the common factor outside of my brackets. Now, again, you see this trick happening a lot, right? That I take a certain, at a certain point in my exercise, I take a whole lot of numbers and letters together and say, well, I can call this P now. Why? Yeah, because now I can rewrite it to 5p. So if I add 5k plus 5n, I can rewrite it to 5p, which means it's a multiple of 5. Q, E, D. I have I have proven that what has to be proven. Okay, the book doesn't use this, by the way, so does, this is a multiple of 5 is also correct. Okay, and I say 43 here, this just has to be 42. I think you already noticed. Okay, try doing exercise 43 and 44 after this. You will see that maybe those are a bit more difficult than 42. But still, I wanted to show you 42 because I wanted to show you the basics so you can use the way that I think and the intermediate steps that I take in trying 43 and 44. If there still are any questions about this exercise afterwards, you can always ask me them, and maybe I will even upload the elaborations of 43 and 44 as well, because I think certainly 44 can be a bit tricky. Okay? So good luck to you once again.